Hey everybody, Mr. Withers here with a quick video talking about fractions and decimals, turning those back and forth between each other and comparing them to each other. Notice today you will need a calculator. If you do not have a calculator with you today, you can download a calculator out of the self-service app on your iPad, but my recommendation would be to have a calculator with you at all times in math class. And there was one on the school supply list, so maybe if you forgot that at home, make sure you start bringing that to class. We will be using those in our fractions unit. If you got it in your backpack or in your binder, go ahead and get that out now. So we're going to start with a bell ringer here, and the problem is as follows. Tara was making tacos for her friends. She bought half a pound of chicken, and the scale showed 0.5 pounds. So what I want you to think about is why are those two things the same? So I'm going to have you pause the video, have a quick conversation. Why are 1/2 and 0.5 the same? All right, go ahead and pause and talk about it. All right, so why are 1/2 and 0.5 the same? I'm hoping what some of our conversation came up with was that 0.5 is half of 1, and 1/2 is showing half of a whole. That would be one way that we could consider this. We could also think about the number 1/2 as 1 being divided into 2 parts, where if we took the number 1 and divided it by 2, we would get 0.5. So that would be another way to think about it. But I'm assuming most of our conversation centered around the idea that if 1 is a whole, then half of that would be 0.5. So the follow-up to that then, part B down here, if she needed 3/4 of a pound of cheese for her taco recipe, what decimal would be equivalent to 3/4? So pause again, have a quick conversation. What decimal is equivalent to 3/4? All right, so my guess is that most of us came up with 0.75, which we know that's kind of a common fraction decimal fact for us. And hopefully some of the conversation you had around that one was similar to what we talked about with 1/2 and 0.5, that 3/4 is 3 out of 4 parts. So if we take 1 whole and we divide it into 4 parts, we know that each of those parts would be 0.25 or 1/4. So if we have 3 of those, we would have 0.75. Again, thinking about this in terms of wholes and parts can be really helpful. So today we're going to chat about different types of decimals that show up when we're dealing with turning a fraction into a decimal. Okay, so there's 2 main terms that we want to make sure that we know. The first term is terminating, and the second term is repeating. And terminating, and we're going to go back to this example in a second, but just the simple meaning of terminating is to stop. So if we have a terminating decimal, it means that when we take a fraction and turn it into a decimal, that decimal stops. It has an end. Whereas repeating does not stop. Repeating never stops. So that is a decimal that goes on forever and ever and ever and ever and ever. It will eventually, hopefully, find a pattern, whether that's a single digit repeating or maybe 2 or 3 digits repeating over and over and over again, because that can give us a hint as to what fraction that decimal came from. So if we want to talk about how do we turn fractions into decimals, one thing that we have to remember is my beautiful poem that I'm sure I recited for you at some point this year, and that is that the fraction line is a division sign. The fraction line is a division sign. So anytime that we have a fraction, like this terminating fraction right here, 7/8, we can think about this like 7 divided by 8. And it is the same thing because that fraction line is a division sign. So 7/8 is the same as 7 divided by 8. So if you take out your calculator, whether that's on your iPad or in your backpack or your binder, and we take 7 divided by 8, you're going to find that 7 divided by 8 should spit out on your calculator 0.875, and it stops. That is why we consider that a terminating decimal, because it has 3 digits and it stops. It does not keep going, it does not repeat. So we were able to very quickly and simply turn that fraction into a decimal by just treating the fraction line as a division sign. We can do the same thing with some of our repeating decimal examples here. So my first one is 1/6. If I take 1 divided by 6 on my calculator, you will probably get something like 0.1666666. It's going to repeat for a while, and then you're going to see a 7 there. The reason that we see that 7 is because our calculator runs out of space. When in all reality, that the 6s would continue forever and ever and ever and ever, and they would never stop. But our calculator screen doesn't continue forever and ever. So when our calculator screen stops, it's going to just round, and it sees that the next digit would be a 6, so it rounds it to a 7 and says that's where we're going to stop. Okay, but we know that the 6s would continue, so this would be the decimal equivalent of 1/6. The way that we show repeating when we write decimals is that we put a line over the number that repeats. So instead of having to write out 6s forever until we run out of room, we can write 0.16 with a line over it to show that the 6 is the digit that's going to keep repeating and keep going forever. Be really careful, because if you put 0.16 and the line goes over both digits, that is 0.16161616, because we showed that both the 1 and the 6 were repeating, when really the only digit that repeats is the 6. And so we would only want to show the line over top of just the 6 so that we are very, very clear on what is repeating. All right, let's take a look at the last one in our repeating examples here, -5/12. So in your calculator, we're going to go ahead and type in -5 divided by 12. So if you do -5 divided by 12, and the negative sign should be down by like your 0 and your decimal point at the bottom, you should get out something like -0.41666666666667. Remember that 7 is going to show up just because our calculator runs out of space. And so we could write this as -0.416 with a line over it. And remember that line only goes over the 6 because that is the digit that repeats. So hopefully that's making some sense. I know in 6th grade we ask you to turn fractions to decimals by finding like tens and maybe finding a fraction below it and a fraction above it and estimating. When we get to 7th grade, we really like us to get in the habit of, let's just use a calculator, let's do some division, and that's going to show us how to turn these into decimals really quickly. All right, so knowing how to do that now makes comparing fractions very, very simple. If I want to compare the fractions in this problem here, 1/4 and the decimal 0.2, it's kind of hard just by looking at it to know which one is bigger and which one is smaller. So what I like to do is either turn them both to decimals or turn them both to fractions. And if I can get them both to have the same denominator, fractions can work fine. But I know that 0.2 is the same thing as 2/10 or 1/5, and that's a different denominator than 4. So it's going to make my life kind of tricky as far as comparing those goes. So I find it to be easiest if I can just turn them both into decimals, because decimals are much easier to compare because we're just level playing field. We're doing the exact same thing. So if I take 1 divided by 4 in my calculator, and some of you might know this one already, 1/4 is 0.25. Now if I compare these, it's pretty easy to see that 0.25 is bigger than 0.2. So I can compare those with a greater than sign. And this would be my correct answer here to compare those two. Let's try the second example here. This one has 2 fractions. So I have -5/8 and I have -6/9. And let's turn these both into decimals so we can compare them. So I'm going to take -5 and I'm going to divide by 8 on my calculator. And this gives me -0.625. Then I'm going to take negative 6, and I'm going to divide by 9. And this gives me negative 0. And I see that my 6 is going to repeat. But what I like to think about is if I look over here at my example on the left, this has 3 digits before it terminates. So I'm going to at least show 3 digits here because it helps me to compare. And then I can just say that that's going to repeat. So if I look at these now, thinking in terms of thousandths in my decimal place, 666 thousandths is bigger than 625 thousandths. So my sign is going to go this way. So this would be the correct answer for that second problem. So what I'm hoping you're seeing is that comparing fractions and decimals is so much easier when we can turn them to decimals on our calculator than it is when we're trying to make common denominators, common numerators, and compare these in a much more complicated way. All right, let's take a look at a couple more examples, and then I'm going to give you some time to work. So what I'm going to ask you to do right now is pause the video, and each person in the room, I'd like you to choose 3 of these 6 problems to do on your own in your notebook. And I would ask that you choose 1 problem from this top section, 1 problem from the middle section, and 1 problem from the bottom section. So 3 problems, 1 from each section. And on these top 2 sections, you're going to be writing them as decimals. On the bottom section, you will be either putting a greater than or a less than symbol to compare those. So pause the video, go ahead and do 3 problems in your notebook, and then come back and we'll go over the answers together. All right, so with 1A, if I take 4 divided by 5 in my calculator, I get 0.8 as my decimal. A really easy way to know those facts is we know 4/5 is the same as 8 out of 10, and 8/10 is how we would read this decimal. So even without using a calculator, that could be one you do really quick just in your head. 1B, if I take 3 and I divide by 16, I get 0.1875. 0.1875. Again, that's a terminating decimal because it does stop on its own. Nothing repeats. 0.1875. All right, next row down. Let's do this one in blue. Negative 5/6. So I'm going to take negative 5 divided by 6, and I'm going to get negative 0.83, and that 3 repeats. Now, I want you to be really careful, and we didn't talk about this before, but I want to remind you now. When we have something like negative 5/6, it is not negative 5 and negative 6. We know with our multiplication and division rules that we've talked about for the last week that if I have 2 numbers being divided with the same sign, it's going to cancel out and we'll have a positive answer. But we know that this number is negative. It tells us in the problem that it's a negative. So we can't put this negative sign with both the top and the bottom. That negative is just going to stick with the top number. So negative 5/6 is just a negative 5 on the top and then just a regular old 6 on the bottom. That way when we do that division, our answer is still negative. So when we do that, negative 5 divided by 6, we should get negative 0.83, and the 3 repeats. And 2B here, we've got 7/9. So I take 7 divided by 9, and I get 0.7 repeating. So you'll probably see 7, 7, 7, 7, 7, 7, 7, 7, 7, 8 at the end. Remember, because our calculator runs out of room, so we can just show that by the 7 repeating. All right, and these bottom 2. If I'm going to compare 7/8 and 0.87, let's turn them both into decimals. So if I take 7 divided by 8, I get 0.875. And then this number is just going to stay the same, 0.87. Sometimes I've had students have trouble comparing these because this has 3 digits and this only has 2. So what I tell people to do is if this doesn't have a 3rd digit, you can put a 0 there because it doesn't change it at all. Now I can see what's bigger, 875 or 870. Obviously, this one's going to be bigger. So that would be our correct answer in this little dot would be greater than. All right, and let's do the last one now, 4b. I have negative 7/15. So I'm going to take negative 7, divide by 15, and I get negative 0.46, and the 6 is repeating. I have negative 5/12. If I take negative 5 divided by 12, I get negative 0.416, and the 6 is repeating. And like I said, if I have 3 digits here and only 2 here, I'm going to go ahead and add a third one. And I know if the 6 repeats that it's going to be another 6 there. This just helps me to compare them because they now each have 3 digits showing. Okay, so the 6s are going to repeat. And it looks to me like this number is bigger. 466 is bigger than 416. But remember, they're negative. So if the number is bigger, that means it's further negative or further away from 0. So this number, 0.416, is actually bigger because it's closer to 0. So this would be my correct sign there. All right. Hopefully this is making some sense. If you have questions, go ahead and ask the sub, and they'll be happy to help you out with this. For the rest of our time today, I'm going to ask you to go into our Canvas page. And you'll see there I've posted a page from our textbook. And these are the problems that I'd like you to work on for the rest of class here. So you're going to do problems 17 through 27, just the odd numbers. Then you're going to jump over to 31 through 37, just the odd numbers. And then at the end, 49 and 51. All of these are part of the assignment. There's no challenge problems today. Just go ahead and do every single thing on here. And this will be homework that is due tomorrow. So if you don't finish this in class, you will need to finish it up at home. So remember, you go into our Canvas page, you click on to week 3, and it should be posted there on Thursday as the book page, and then you'll see this assignment listed there as well. You do not need to hand this in on Canvas. Just keep it in your notebook, and I'll check it in class tomorrow. So again, this is due tomorrow. And you'll have the rest of class today to work on this. So thanks for your attention. If you have questions, ask the sub, and I will see you tomorrow. Have a great day.